Thank you, everybody, for coming to my talk. And so ideally, I will talk about things AI related in Java. So my talk is basically on how to build AI agents using Jakarta EE, and I'll explain why specifically Jakarta EE and with using LangChain4J-CDI. So um, quickly, I am basically an enterprise solutions architect and developer. I've been doing this enterprise development for close to 20 years. 20 years will be exactly February next year. And primarily, I'm focusing on Jakarta EE because that's what I started with. And then I just went from there because I believe Jakarta EE is now it's very lightweight, and you can pretty much build any enterprise application using Jakarta EE on any application server. You'll have a lightweight application running in production. I'm a Jakarta EE ambassador. I'm a tech speaker. I write content, and just to preface also, I run a nonprofit called DevOps for Kids South Africa. So I'm trying to teach kids to code, especially in underprivileged places. And I'm a LangChain4J-CDI committer. So a lot of things that I'll be talking about, I've been part of the members who have contributed in building those kind of functionality for LangChain4J-CDI. So these are my social media where you can find me. I'm mostly prevalent on X and LinkedIn and Instagram, but you can email me or what, and I'll communicate with you. So feel free to say hi. Come and say hi. So LangChain4J. LangChain4J started around 2020, if I'm not mistaken. So it was inspired by LangChain, the Python code LangChain, and then it became a fully open source Java library for large language model. Basically, what it does is it gives you a unified API for LLM integration. So for developers, that means that you do not need to know the structure on how to communicate with specific LLMs. There are providers. LangChain has so many providers that does the communication effectively. So you just need to specify the model and certain parameters, and it knows how to communicate with it. And not only that, it has other toolboxes that can allow you to do RAG, prompt engineering, tool calling, MCP, all of that wonderful features. So again, it makes it easier for developers to just build the application and interfaces with LLMs much easier. And also, if you want to do RAG and document splitting, document loading, and vectorization of your document, it also has that. It integrates with popular vector stores that for better embeddings. So if you want to do document ingestion into vector stores for embeddings for your LLM, it has that kind of support. And it also has a high-level API called AI services, so you can build your AI services, and it bundles all the low-level common libraries for your LLM communication for you. So, and the reason I'm talking about LangChain because it's been widely adopted by various industries. You'll probably be seeing Microsoft talk about it, the likes of Oracle and IBM's and all of that stuff. So it has now got huge adoption. Quarkus is also one of those companies that actually also adopted, even worked on the contribution to LangChain. So as I said, LangChain AI services, this is fundamentally important because it is LangChain has what we call low-level API components that for LLM integration. For example, your chat model is what interfaces with your LLMs directly. So if you want to chat directly with LLMs, irrespective of from which LLM providers, you will primarily interface with the chat model. So with AI services, it's basically a declarative API where it knows that given a chat model, chat memory, or a tool provider, it knows exactly how to bundle all of these things together so that you have an effective AI agent. As I've said in previous talks, that an AI agent needs an LLM to integrate with, a memory to have a conversational state because LLMs are stateless, and obviously prompts and some vector store to 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 keep some embeddings. So LangChain4J provides the facility to bundle all of these basic components and into an AI services for you. An example of AI service, for example, you would just create an interface. For example, in this case, we have an assistant with a method chat. You see an annotation which is a system message. Basically, it's a system prompt. So the system prompt tells the LLM that these are the instructions that LLMs needs to adhere to. Or basically a programming of what the LLM needs to execute once it receives a user message. So once you have that, like I said, to interface with your LLM, you need a chat model. So you will have a builder specify your API key. In this case, you see it's called an OpenAI chat model. So you need an OpenAI key, a model name. So right now, this example was when 4.0 was out. Probably now it's ChatGPT 5. And then once you build the chat model, you use the factory method to create your AI services. So you register your interface with your model. Once created, then all you have to do. So basically, your AI services creates a proxy that of your interface that will effectively communicate with your LLM. Once you have that, all you have to do is you just call your assistant and say chat in the specific case. So that's basically it. But obviously, there is this kind of method of doing so, writing all of this code. But for enterprise developers, we are familiar with interfaces, and we are familiar with providing configuration and doing injection, because once you do an injection, then your configuration, the container knows how to take your configuration and build your object for you, a proxy object for you directly that is directly available for injection. So we said, what happens if we take these AI services and then we introduce configuration as well, and then apply some context and scope to these AI services? For example, we can make it request scope or application scope, and then on top of that, as an additional feature, why don't we add resiliency like fault tolerance, whether to do some retries and fallback. So, and also maybe add observability, so you can have traceability on and how many input tokens that was sent to your LLM, the response output tokens, and all of that stuff. So you can use Prometheus to actually observe your input and output LLM calls. What we did, we created a project called LangChain4J-CDI. LangChain4J-CDI is a Jakarta EE working group and microprofile working group project that started as a small LLM. And then earlier this year, we donated it to LangChain4J and we named it to LangChain4J-CDI. So it's basically a CDI extension that takes your AI services and and puts all the funky, beautiful CDI features on top. So we've introduced a CDI stereotype called at register AI servers. And so once you take an agent and you annotate it with at register AI service, then the container will automatically say, this is an LangChain4J AI service, and then and if it finds all the available LLM components that's also CDI injectable, it will inject it for you and give you a CDI ready AI agent. So the container handles the proxy creation of the AI service, and all you have to do is add inject. And I'll show you later in the slides how it gets done. You'll see the requirements is Jakarta EE 10 and higher, because as LangChain4J keeps evolving, which they do very rapidly, then LangChain4J-CDI will keep on evolving as well. And it's been tested on these popular Jakarta EE approved AI servers, and most of them also adopt micro profiles, so you do not have to worry about do I have an issue running micro profile or not. So the register AI service annotation is basically a notation where you can specify which LLM components that you want to inject on your AI agent. You'll see that each annotation attributes correspond to the type of the LLM component. So for example, the chat model name basically will inject anything of type chat model if the CDI container identifies or finds any being of that specific type. So content retriever name will inject anything of type content retriever. So we gave it a simple name for developers to know that name probably corresponds to that specific LLM type. So any value with an empty attribute means that the CDI will not look for it and will not even try and inject it. Any attribute with a CDI name, it will find a beam with that CDI name. And any attribute with a hashtag default means I don't find me any beam of that specific type, irrespective of name. If it doesn't have a name or not, it doesn't matter, as long as there is there is a class type of that specific type that is able to be injected. So meaning there must be one reference implementation of that specific type. For example, given the example of the assistant on the previous slide, we just annotated it as register AI service. We given a chat model name and we said application scope. So once you deploy the application, your assistant will be application scoped, and your chat model name that you created at the beginning on the previous slide, where you had to create a chat model with a builder, it would inject that because it will find anything but the name OpenAI chat model. So there are two approaches to create a chat model. Either you create a producer method and then write the same code that you wrote in a previous example so that it can be injected, or you would use, for example, microprofile config. Microprofile config allows you to create a configurable LLM object types that can be used by your AI agent or your AI services. So all your components will have to start with a prefix def on LangChain4J.plugin. And then once that, you say dot, and then your CDI bean name. So once you have the CDI bean name, then you can specify all the attributes. So all the attributes so there's two different ways. After the CDI bean name, the two additional fields that's required is class. Class will be which specific type do I want to load and register at the CDI container, and then .scope means which scope do I want it to apply. If you do not apply anything by default, I think it's request scope to application scope. I'll have to double check, but then you have to specify a class, and then once you do that, after the CDI being named, then you say .config and then dot and then all the attributes. Anything .config other attribute is basically says I will take the class name, I will find its relevant builder. Like in the previous example, we said OpenAI chat model .builder dot, and then you specify API key to give the OpenAI API key. So basically .config means find the relevant builder, and then the API key will be the field that you need to populate. So you'll see like some names got API-key, so meaning it will find a variable or a method that says API and then capital K. So anything dash with a small letter, it will be find any property or method that's got a capital of that specific letter, and then inject a value. So that's basically what it means. Once it has that configured, then on load, the extension will basically load all of this configuration, populate the builder, generate the object of that specific class that you specified, and then apply the scope, and it will be ready to apply on your AI services. The same thing for memory, because LLM are stateless, and if you want to have a conversation with your LLM, you need to add a chat memory. Chat memory is an object type in LLM. All you have to do specify is which class you want to have. Like in this example, the CDI bin name is chat-AI-service-memory. Then I said the class will be message window chat memory. Once you have that, I specify the scope, and then the builder will find anything that's got max messages, and then it will assign 10, meaning that I must skip the last 10 conversation that I will have to prepend on the message, on the LLM message, and then add the current prompt message, and then send it to the LLM. That's how the conversation happens. So it takes your previous conversations, add your current conversation, and send it to the LLM. So in order to have a stateful conversation. Now, anything like the config, resiliency, and observability are optional extra because microprofile modules, extensions. So, but the primary core of LangChain4J-CDI is basically CDI, basically. But if you want to add resiliency, for example, the exact same way you would add on your existing RESTful service, web services, you can use fault tolerance. So all you have to do is the same way you would do on your, as I said, on your RESTful web service, all this annotation also applies. Once you've assigned that, it will trigger the interception for fault tolerance and do all and trigger all the operations necessary for your resiliency. So there's no other extra configuration needed, none of it. But if you do a fallback, because since it's an interface, you need to give a default method for execution, because we do not, you will have noticed that we do not create a default implementation of all our agents. It's a proxy that's generated. Observability is using microprofile telemetry, so it can register your span and your metrics to your your observer, your telemetry observer, whether Prometheus or otherwise. So you'll see certain LLMs supports chat model listener. If it doesn't support your chat model listener, then you cannot specify telemetry. But if you do, you can have two options. You can either add a span chat model listener, a fully qualified name, or a matrix chat model listener. If you do that on your config.listeners, you can specify, you can do the lookup at all, meaning find all of the chat listener that's registered and automatically inject them, or specify each one separately but comment delimited. So you can say, I only want a span chat model listener. You can specify the fully qualified class name of that and then leave it there. Or you can specify the span and matrix but comment delimited. Or if you write another third option, you can do that, comment delimited. But ideally, people do lookup.all and then it will automatically find it. And they both are implementation of the semantic convention for generative AI, which you can find online. So to get started, like I said, the CDI portable extension is a core one. Without it, nothing can get injected. Nothing will be discoverable by any chance. So have the core one first, and if you want config, then you have to add the following artifact ID. For config is LangChain4J-CDI config, fault tolerance is LangChain4J-CDI fault tolerance, and telemetry is LangChain-CDI-telemetry. So those are additional libraries that you can add into your main WinPom on top of LangChain4J-CDI portable extension, which is your CDI core to activate LangChain4J-CDI services. And currently we're on 0.0.7, but we're working towards version 1 once we get MCP ready for injection. Putting it together, let's say you have a RESTful web service and you want to inject your assistant. All you have to do is say @inject, and like I said, there's no implementation of assistant. The CDI container will do all the managers for you. Like here, there's a method you can do an HTTP GET for a chat, and it returns you the response directly. Bob's your uncle. So for resources, here are the links for LangChain4J, for LangChain4J-CDI. If you want to understand how to build LangChain4J very extensively, this is Race wrote a beautiful article on Java Pro, and I've written an extensive article on how to apply AI agents using LangChain4J-CDI. If you want to include additional features like RAG, for example, or embeddings into your AI agent. All of these are written into the article. It's a PDF. You can download it. It's about, I think, 8 pages long, so you can have a good read. It's got examples on there, so you can actually get it from there. Not to be confused with Spring LangChain4J and Micronaut LangChain4J also have their own implementation, except that they don't have @register AI service. They have @AI service annotation. Quarkus and Helidon have the same annotation, but different type of attribute methods. So Quarkus also have the independent version of register AI service, same as Helidon, but they're also CDI injectable. So like I said, what we've done also works on Quarkus and Helidon, but they also have their different implementation, which you can find on the following slides, on the following links provided. And then finally, on top of that, you are all welcome to come and contribute to LangChain4J-CDI. It is a fully open source project, so feel free to, if you want to join and contribute, you're more than welcome. but also now Jakarta EE is trying to build a framework, an agentic AI framework, which just got under development. So it's Reza and the Payara team are trying to formulate a framework for it. So it's basically a venture neutral way to create reliable AI agents that you can deploy and run using Jakarta EE. So taking experience from, for example, with LangChain4J, LangChain4J-CDI, and other Java-based AI service AI agents like in Babel. The idea is to create a framework for that. It's the exact same way as how servlets run the web and JPA runs persistence. It's that kind of same mindset and that we're trying to achieve. So for more information, you can actually go to the specifications page and read all about it. So the demo, well, I won't have the time to run it, but you can check the Sindi AI chatbot. In that demo, I used Gemini 2.5. Now Gemini 3 just recently got out, so you can change your micro profile configuration if you want to use Gemini. Specify your API key on the config file and whatever, and rerun it, and it will register with Gemini. So thanks everyone for listening to my talk. If there is any question, I'll look at the chat now.